Okay, the question we have to ask ourselves with these types of problems is, what are they actually asking for? And the question said we're looking for the dimensions of a box, so that will be the length, the width and the height. And the box has got to be made using the least amount of material. Well, immediately that suggests that what we're looking for is that the surface area has to be a minimum. So we need to now come up with a function which has surface area in it. Well, let's have a quick picture. It's square based, so we have a square box, and we know nothing else about it except that we have 4 litres, which is 4,000 cubic centimetres. After that, we do have to introduce our own variables, so let's call it x along the base, and it's square base, so x would be there, and let's use h for height. So there we have it. That's our picture, and we're looking for the surface area to be a minimum. Well, let's find surface area. The surface area, let's call it A, will consist of, let me just draw that in to make it look right. There you go. Let me go back to that. The area will be base, which is x squared, and then we have 4 identical sides with each area being length times width, or base times height, which is xh. So that's our area. Now, unfortunately with this, we have area in terms of 2 variables, x and h. So we can't differentiate with respect to x at this moment. So what we can do, though, is we have another piece of information. We can work with the volume, and the volume is length times width times height. So we have that 4,000 is x times s times h. And from that, we can deduce that h is 4,000 over x squared. And hopefully you can see where I'm going with this now. If we substitute h into a, we have a equals x squared plus 4x h. And immediately we can do some tidying up. So we can get rid of those, and we end up with the area equals x squared plus 16,000 over x. Well, I'm going to write that as 16,000 x to the minus 1. And the reason for that is we're going to have to differentiate that. And so when we differentiate, then we have that dA dx is a straight differentiation. X squared becomes 2x. And then we have minus 16,000 x to the negative 2. And what we're saying is for a minimum, this will imply that dA dx is 0. And we're looking for what happens when that is true. So we now have 0 equals 2x minus 16,000 over x squared. And notice I put it in a form that I can understand. So rearranging, this then implies that, well, basically once you've put it through, you've got x cubed is 8,000, which means that x is a cube root of 8,000, which is 20. Okay. Now that's all well and good, but are we certain that this is a minimum or a maximum? So we just need to check that, and we can do a couple of things here. We can do a sign diagram and check for that. So if we look here, what have we got? We've got when x is, let's have a look, let's just put 20 in there. Alright, and that's x. And we've got dA dx in here. And gradient is 0 at that point. So if it's less than 20, if x is less than 20, what are we going to end up with? We're going to have, let's say 10. So we have 16,000 over 100 is 160. 2x minus 160, so 20 minus that. So this will be a negative gradient. Okay. So in other words, it's going down and across. Now let's have a look now. What we're looking for now is something bigger than 30. Let's go with 40. 40 squared is 1600, which gives us 10 here. And 2 times 40 is 80, take away 10 is 70, that's positive. So we have a positive slope there. And so we can clearly see that this shape would indeed be a minimum. Okay. Now we could do different things there. We could check using the second differential and look at the second derivative and examine that. But this is enough to show that that is a minimum. We haven't answered the question yet because the dimensions, in order to make this work, well, we have x is 20, but we also have that y is 4,000 over x squared, which implies that y equals, whoops, let's not put x squared there. Let's put the value of x in there, so that's 4,000 over 400, which is 10. So our dimensions are going to be 20 centimeters by 20 centimeters, that's our base, by 10 centimeters, which is the height. And so that is the actual result and the answer we're looking for.